Welcome to Technical Physics, EGG 131. I'm Art Eggers, and I will be your instructor for this semester. You have enrolled into the distance education or the online version of Technical Physics, so this is probably as close as you're going to get to me throughout this semester, unless you happen to stop by my office. In this class, you're going to find out very quickly that the course is very, very math intensive. I've tried to send you some emails to let you know and to kind of prep you for the course so that you had an idea of just how much math you were going to be using in this class. From the very first lesson, you're going to see a lot of math and a lot of review of the math that you've had, hopefully over the past few semesters. Of course, you're immediately going to see your algebra. You're going to see some of the introductory trig relationships, and something that you may not have too much experience with is vectors. And we're going to see very quickly how the trig relationships, that of the right triangle relationships, tie together and teach you some tricks for breaking things down component-wise into x and y components, so that you can solve for problems that have an x dimension as well as a y dimension. And we break these down using the standard trigonometric relationships of sine and cosine. And in doing so, we end up looking at what is actually the resultant vector that forms by, or is formed by, each of those components. So this is why it's important that you are able to come into this class immediately understanding those mathematical relationships. As you're going to see for the course is really delivered in three different environments. In the previous semesters when I've taught this course, I used almost exclusively the environment afforded to you by CSN, the CSN Canvas, sometimes called the LMS or the Learning Management System. And I've made some primer videos for you so that you know how to get to Canvas. So this is going to be probably the number one environment that you're going to use to determine which assignments are due and when they are due, because they are all broken down and given to you in what I call a module or a modules format. So you will see module after module after module as we progress through the course week after week. A lot of the course material, other than the discussions, you have weekly discussions, they are administered and graded in Canvas. You will be using a Pearson website called Mastering Physics. In Mastering Physics, I have set this up so that all of your pre-lecture materials, your homework materials, your weekly assessments, and your course exams are all administered in the Mastering Physics environment. So you're going to be working in both areas to get the assignments done and work through the material that you are going to need. For the Mastering Physics portion and the modules, we are actually going to work through chapters 1 through 10. We're going to skip 11 and 12 and do 13 and 14. In each of these cases, every 4 chapters you will be faced with an exam. So there are 3 exams. So when you go through chapters 1 through 4, then you will have an exam. Chapters 5 through 8, you'll hit exam 2, and then chapters 9, 10, 13, and 14 for lab 3. They are cumulative only with respect to the fact that you have got to know all of the material and keep track of and be proficient with all of the techniques that you learned previously. Will there be specifically a question on exam number 3 from exam number 2? Not specifically, but there is information that meshes in between them that you certainly need to know in order to solve the problem, because it'll take information from the previous chapters and say, okay, now I want you to solve for what you learned back here in terms of motion in 1 or 2 directions, and apply it to some of the physics of, say, sound waves and things of this nature, or rotational and circular motion. So everything that you learn along the way is in fact going to be applied as you progress through the course. Okay, so what we're looking at here is a Canvas environment, a Mastering Physics environment, and I have also included some labs. And the labs are given to you in a videotaped environment, because you're not in the classroom here where you normally sit down and work with the labs as teams or group members. So what I have done is I have created several fashions or versions of videos that will help you do the labs and are required for you to watch so that you can actually complete the lab report. Every lab will have an associated lab report that goes with it. So you will see that there is a worksheet that describes what the lab looks like, what the procedures are, what the theories are, what the results are supposed to be. You will find that I have several types of demonstration videos, whether I've done them just like you're seeing right now with a personal video of myself actually performing the lab, or something that I have created in PowerPoint and then explain to you the procedures and the processes. Some of the labs where you have to make measurements, you actually have to view the video one step after the other, because incrementally they build the lab. The other parts of the lab, I've merely given you an explanation of how we would have done the lab in class. I will give you some typical data, and then it is your responsibility to actually complete the lab results and do the math associated with it. I strongly, strongly encourage you in the labs to use Microsoft Excel to do the math, because in this age, understanding and knowing how to solve these types of problems and report these types of experiments is important, that you know how to use Word as well as Excel in order to put together a very professional report. So you will also be using Word, and for the Word and in some cases the Excel, I have given you a specific format that I want you to follow. So when I've given you the format at the beginning of the class, that's the format that I want to see throughout the rest of the course. Okay, so you're going to have several labs that follow each of these modules. Okay, so in the Mastering Physics portion, make sure you work through the Mastering Physics. If you have a problem with a particular test question, the Socratic method inside of the Mastering Physics presentation allows you to get some hints. So I need you to become very familiar with and use Mastering Physics for the information. Of course, the first thing that you have got to do is read the text. I need you to sit down, read the text, and I need you to work the example problems. I've included in the modules many of the practice problems that I've actually used in the on-ground classes to help you understand, if you're a little rusty with the math, how you proceed through these mathematical relationships so that you can get to the solution to the problems. Okay, so read the book, work the examples, take a look at the practice examples, go through the modules, work the problems in Mastering Physics, and perform the labs. You're going to be very, very busy in this course. In the on-ground environment, the course is tough enough. For you to be doing this course online adds another level of difficulty, and for that I commend you. As far as the discussions, I tie the discussions to your attendance. And what happens is, when you pop open the discussions in Canvas, you're not going to see anything initially. You have got to post first a comment about any of the 5 open-ended questions that I've given you. Once you make a comment about the labs, the material, anything that is pertinent discussion-wise, then you will see everybody else's discussions that have already posted. And I do that on purpose. I want to get your thoughts first before you see what anybody else has posted. That first discussion will give you 70% of your grade for that particular post. Then what I need you to do is look at everybody else's posts, and as I see sufficient and substantial posts, meaningful posts that you've commented on other people's posts, then I will start adding points back to your post grade so that in the end you get your 100% for that particular post. Okay? So the first time you go in there, don't fret that you can't see any posts, because it's waiting for you to post. As soon as you post, you'll see everybody else's. How is it tied to the attendance? Well, I have to keep track of the attendance in the class, and I need some mechanism. So I've tied it to the discussion. Once I see your discussions post in there, then you will also get credit for your attendance. So this class has a lot of information. It has a lot of material that's going to be thrown at you. Okay, a lot of topics, and we're going to go from everything from understanding the accuracy of measurements and significant figures, dimensional analysis, first motion in 1 dimension, motion in 2 dimensions, dealing with some of the relationships where maybe you are plotting data and it forms some type of line. You're going to have to go to the relationship, the old mathematical relationship, y equals mx plus b, and determine what you have for the slope of your line. We're going to get into that by the time we get to the second lab. So 1-dimensional, 2-dimensional analysis, motion, we get into work, we get into force, we get into energy, we get into heat, we get into sound, we get into fluids. There's a lot of information presented in this class. If you've never had a physics course before, it's going to be quite an eye-opener for you, and hopefully a treat, especially for those that like math and science, because this is the perfect marriage of math and science in a course like this. So, what I encourage you to do is accept the challenge. Get in there and start working through the information and getting back up to speed and dusting off your math and science skills. I encourage you to keep a notebook. Keep a notebook as we're going through and learning new mathematical relationships, that you keep them handy, because like I said, you're going to use them over and over throughout the course. Okay? So keep some very good notes. Although your textbook does some good review, on the material, sometimes in your own hand it makes more sense to you when you go back and look for it. In the discussions, this is your area. You're not in my classroom. So this is where you have a chance to talk with each other, share with each other, and help each other through this class. In helping each other through this class, you're going to gain confidence, and you're going to share that confidence with others. I want to see everybody make it through this class. Okay, so get in there, share with each other. Typically what I see in my discussion sections is, I can't shut you guys up, and that just tickles me to death. I love seeing you guys talking with each other and sharing what you've learned, using examples from life, using examples from your particular discipline. Those of you that are in the health sciences, those of you that are in engineering and or IT, how physics works for you in your discipline and in your life. Okay, I'm going to shut up now. You're going to see lots of me in different areas throughout the class. You know how to get a hold of me. I've given you several pathways that you can get in touch with me. I will help you all I can in the course. Okay? So, looking forward to this semester. Thank you very much, and we'll see you on campus.